The amplifier can be characterized in 4 different ways depending upon its input, which can be a current or a voltage, as well as its output, which again can be a current or a voltage. This gives us 4 possible combinations of amplifier. At first it looks fairly intimidating, but we can see some commonality among all 4 different types of amplifier. Firstly, all of them have a single resistor as the input with a current I sub I and an input current called I sub I and a input voltage across the resistor called V sub I. Then as we look at the output, we can see that those outputs which have current for their output are represented by a Norton equivalent, a resistor in parallel with the current source in both cases. Notice it is a controlled current source, but it is a current source nonetheless. And its output is defined as an output current, I sub O, and an output voltage, V sub O. When we look at the voltage output, we'll see something similar. Now we see a Thevenin equivalent with, again, R sub 0, but now it's in series with a voltage source, the Thevenin equivalent. Once again, the voltage source is a controlled voltage source, but it is a voltage source nonetheless. These amplifiers get their name by taking the desired output and dividing it by the desired input. For example, if we look at the voltage amplifier, what we are going to see is that it has an output of voltage and it has an input of voltage. So voltage over voltage, output over input gives us a voltage amplifier. Meanwhile, if we go up to the current amplifier, we want a current out, and it's being supplied by a current source, and we have a current in, and we have amps over amps, or a current amplifier. Current in, current out. Meanwhile, if we go down to the trans resistance amplifier, what we see is an output voltage for an input current. If we take output, divide it by input, we have volts over amps, and the result is resistance, hence the name resistance or trans resistance amplifier. Considering the transconductance amplifier, our desired output here is current. The desired input is voltage, so we divide output by input and we get current over voltage. The units of current over voltage are conductance or Siemens, and hence the name transconductance amplifier. So if you can start to see the similarities in the pattern, this slide is not as intimidating as you might think. Remember, all of them have R sub I, an input resistor, with an input current, I sub I, and an input voltage, V sub I. All of them have an output current, I sub O, and an output voltage, V sub O. If we are expecting a current output, it will be supplied by a Norton equivalent of a current source in parallel with R sub O. If we're looking at a voltage output, it will be a Thevenin equivalent of R sub O in series with a voltage source.